आज का जो टॉपिक है दैट इज टर्मिनेशन ऑफ चार्ज टू मास रेशियो फॉर इलेक्ट्रॉन्स। ये जो एक्सपेरिमेंट है टर्मिनेशन determination of charge mass ratio, that is E oblique M, E by M for electrons. So in this case, J. Thomson for the first time experimentally determined this charge to mass ratio, and this is also called E by M ratio for the electrons. So for this, what he did, he subjected the beam of electrons. This is beam of electron released in the discharge tube, that is called cathode rays, to the influence of electric and magnetic field. Right? What he did, he subjected the beam of electrons released in the discharge tube as cathode rays to the influence of electric and magnetic fields, and these electric and magnetic fields are perpendicular to one another as well as to the path followed by the electron. So what he did, he subjected the beam of electrons released in the discharge tube as cathode rays and see the effect of electric and magnetic field. See the effect of electric and magnetic field on this beam. The influence of electric and magnetic fields, and these fields are perpendicular to each other as well as to the direction of propagation. Okay, say the electric and magnetic field, they are perpendicular to each other as well as the direction of propagation. Okay, or the path followed by the electrons means all the three are perpendicular to each other, just like Cartesian coordinates x, y, and z. Means if it is like this, if path of electron is this one, then electric and magnetic field, they are perpendicular to each other as well as to the path followed by the electron. So now, according to J. Thomson, the extent of deviation, say the A, B, and C, A, B, and See, the extent of deviation under the influence of applied electric field and magnetic field, that depends upon the following factors: extent of deviation, extent of deviation. It depends upon the first magnitude of the negative charge on the particle. So greater the magnitude of charge, or we can say negative charge, greater the magnitude of negative charge on the particle, so greater will be the interaction with the electric or magnetic field, and thus greater will be the magnitude of deflection. Greater will be the magnitude of deflection. See, when negative charge increases, because no, it is moving from cathode towards anode, so that means it is, these are cathode rays, and cathode rays are beam of electrons. But if any negative charge is moving in between the electric or magnetic fields, so greater the magnitude of the negative charge, greater will be the magnitude of deflection. Okay, this is the first observation. Now second one, smaller the mass, more will be the deflection. And third is strength of the applied field. So, as strength of the applied field increases, then more will be the deflection. So these are the three things: greater the strength of the applied field, applied electric or magnetic field, more will be the deflection. The particle will undergo. So these are three observations. These are three observations made by Thomson. First was, as the charge on the particle increases, deflection will be increased. More will be the charge on the particle, more will be the charge, negative charge on the particle, more will be the deflection. Second is, smaller the mass of the particle, more will be the deflection. And last one is that as strength of the applied field increases, just turn on the YouTube live as well, but then there is a time lag. I will manage. Okay, see, greater the strength of the applied electric field or magnetic field, more will be the deflection which the particle will undergo. Okay, these are the three observations that are made by Thomson. So now, under the influence of, my voice is repeated by your mic, please. Hello. Beta jab, now is it okay? Hmm. So now, under the influence of applied electric field alone, when only electric field is applied, then electron deviate from their path and it strike the fluorescent screen at a certain point. Let us say, wait, see, this is fluorescent screen. So when temperature, sorry, when applied field is only electric field, when only electric field is applied, that means magnetic field is turned off, then where the electron will strike. So see, electric field is applied, only electric field. Magnetic field is turned off. So obviously electron will be attracted towards the positive plate. So they will strike at A. Where they strike? They strike at A. Then by applying magnetic field, when electric field is turned off, then they will strike at C, because electric field and magnetic field, they are perpendicular to each other. So as they are perpendicular to each other, so in the presence of electric field only, they will strike at A. In the presence of magnetic field only, electron beam will strike at C. Now, when both the fields are turned on simultaneously and the two fields are adjusted in such a way that their mutual deflection cancel out, then path of the electron beam remain undeflected, just like in the absence of electric and magnetic field. That is, they strike the screen at point C, sorry, at point B. C. This is in the presence of magnetic field. This in the presence of electric field. And when both the fields are on, say if electric field is dominating, when electric field is dominating, so obviously in the dominance of electric and electric field, it is striking in between A and B. If magnetic field is dominating, then it will strike between B and C. And if both the fields are adjusted in such a way that they cancel each other's deflection, then they will strike at B, and the path of the electron beam remain undeflected. So from the magnitude of the two fields, it is possible to calculate the charge to mass ratio for the electron. and the value comes out to be the value comes out to be 1.76 into 10 raised to power 8 coulomb per gram. 1.76 into 10 raised to power 8 coulomb per gram. So this is the way to calculate charge to mass ratio for the electron. And this charge to mass ratio is calculated by J.J. Thomson. And credit for the discovery of electron also goes to J.J. Thomson. Okay, so this is the determination of charge to mass ratio for electrons. Now next is calculation of charge on electron. So, now calculation of charge on electron. So the charge on the electron, it was determined experimentally by, yes beta, who discovered the charge, who determined the charge? R.A. Millikan. Charge on the electron, it was determined experimentally by R.A. Millikan, by Millikan's oil drop method. By Millikan's oil drop method. The oil drop method is used. So let's take figure from NCRT. So it was determined experimentally by R.A. Millikan, and experiment name is Millikan's oil drop method. So this is the apparatus used to perform this practical or experiment. In this method, oil drops in the form of mist. See, this is atomizer. First is the, this is atomizer. So what is the use of atomizer? Oil droplets in the form of mist were allowed to enter the chamber through a fine hole. So this is the first thing. These are the oil droplets. Atomizer is used to form these fine droplets, and they were allowed to enter the chamber through a fine hole. This is the fine hole through which these oil droplets are allowed to enter. Okay. Now, next part is an electric field was applied. These are the two plates. See, these are the two plates. 1 and 2. These are the two electric plates. Okay, these electric plates are for electric field. So an electric field was applied. Now by measuring the rate of fall of the droplets, Millikan was in a position to determine their mass. And in the meantime, a beam of X-rays, see, a beam of X-rays. This is the beam of X-ray. It was introduced in the chamber. See, this is introduced in the chamber, which ionize the air inside it. This X-rays is used to ionize the air inside the chamber. So when this gas is ionized, air is ionized, ions were produced. And oil droplets on colliding with these ions also got charged. Now, initially oil droplets are neutral. Now, because of this ionization, oil droplets are now charged, either positive or negative. Because when air is ionized, gas is ionized, cation and anions are formed. So oil droplet now becomes charged. And now by carefully monitoring the effect of electric field on the motion of these oil droplets. So see, if it has a negative charge, see, the plate below is negative and upper plate is positive. And this is telescope used. Now by carefully monitoring this effect of electric field on the motion of the droplets, he was in a position to determine the electric charge on the droplets. And he further stated that charge on the droplets, that is n into charge on one electron. E is charge on electron, and n is the number of electrons, 1, 2, 3, so on. It denotes the number of electrons. The charge on the electron was found to be 1.602 into 10 raised to power minus 19 coulomb, and its value or magnitude was found to be negative. It was found to be negative. So this is the way to calculate the charge on the electron, and it was determined experimentally by R.A. Millikan by Millikan's oil drop method. Okay, and the charge on the electron, it was found to be total charge on the oil droplet is integral multiple of charge on one electron. And in this way, he calculated the charge on the electron, and it was found to be 1.602 into 10 raised to power minus 19 coulomb. Now, charge of the mass free. Let us calculate the mass of the electron. Now, did you understand this experiment? It is simple that first of all, there is an atomizer that leads to the formation of oil droplets. these oil droplets were allowed to fall to this fine hole. Beta, please turn off your mic. Now, when these X-rays were allowed to enter the chamber, they will ionize the gas air inside the chamber, and therefore, because of this ionization, those oil droplets got charged, either negatively charged or positively charged. So, by telescope, he monitored the motion of the oil droplets by varying the applied field, because there is a negative plate and upper plate is positive. So, motion of oil droplets due to the charge on them is different in different magnetic electric field, and that's why he got an idea that how much is the charge on the oil droplet, and then he see that minimum charge, that is multiple of that on the oil is 1.602 into 10 raised to minus 19 coulomb, and that is the fundamental charge, and that is the charge on the electron, and the charge magnitude of the charge is negative. Okay, now next part is calculation of mass of the electron. Now we have, first we have charge to mass ratio that was determined by J. Thomson, and now we have charge on the electron. It was determined experimentally by R. A. Millikan. Now from this charge and charge to mass ratio, with the help of these two values, we can calculate the mass of electron, because these are the two experiments. It determined, first experiment determined the charge to mass ratio, and second experiment determined the charge on the electron. First E by M and second E. So from these two experiments, we can calculate mass of electron, and mass of electron, that is small m, is equal to E divided by E upon M. So, you know, E is 1.602 into 10 raised to minus 19 coulomb, and charge to mass ratio is 1.76 into 10 raised to power 8 coulomb per gram. So from here we get 9.11 into 10 raised to power minus 28 gram. 10 raised to power minus 28 gram. So in kg it is 9.11 into 10 raised to power minus 31 kg. It is 1.602 divided by 1.76. Okay, it is 9.10 only. 9.102. So 9.10 into 10 raised to power minus 31 kg. Now, mass of electron, it is approximately 1 by 1837 times the mass of an atom of hydrogen. It is the lightest element known. So mass of the electron is so small that it is almost negligible. So mass of the electron is 1 upon 1837 times the mass of hydrogen. Mass of hydrogen. And that's why mass of the electron is so small that it is almost negligible. We have already done its definition. That is, it is a fundamental particle present in an atom which carries 1 unit negative charge, that is 1.602 into 10 raised per minus 19 coulomb, and negligible mass 9.10 into 10 raised per minus 31 kg, which is 1 upon 1837 times the mass of hydrogen. Okay, so in this way we have calculated charge to mass ratio, charge of the electron, and mass of the electron. So next part is electron as a universal particle. Electron as a universal particle. Electron as a universal particle. So, electrons are the constituents of cathode rays that we have already discussed, which are formed in the discharge tube, that you know. And in addition, electron may also originate, where they originate, from a number of sources like heated metal filament, by exposing active metals like sodium, potassium in ultraviolet rays, from radioactive substances in the form of beta rays. So values of the charge, mass, as well as their charge to mass ratio always remain the same, whatever may be the source of origin. That's why electrons may be regarded as universal particle. Is you will write values of charge, mass, and their ratio always remain the same, whatever may be the source of origin. Therefore, an electron is regarded as universal particle. That's why electron is regarded as universal particle. So far we have done discovery of electron, proton, then cathode rays, charge tube experiment, origin of cathode rays, properties of cathode rays, discovery of proton and anode rays, the properties of anode rays. Now come to the radioactivity. Next part is radioactivity. Can you define what is radioactivity? What is radioactivity? Yes, beta. It is the phenomenon of only gamma rays. It is a spontaneous emission of certain highly active radiations, that is alpha, beta, and gamma, by radioactive substances. The substances which emit any one of them, alpha, beta, or gamma, they are called radioactive substances. So, what is radioactivity? The phenomenon of spontaneous emission of certain highly active radiation by radioactive substances, that is called radioactivity. So these radiations are alpha rays, beta rays, gamma rays. Can you tell me what are alpha rays? Hello, beta. Alpha rays are not helium particles, but they are helium nuclei. It is actually helium nuclei. No doubt it is represented as 2He4. Okay, but it has 2 unit positive charge and 4 unit mass. 2 unit positive charge means 3.2 into 10 raised to power minus 19 coulomb, and 4 unit 6.6 into 10 raised to power minus 24 gram, right? Okay, now next, helium will have 2 electrons less. शत्रुंजय सर बिल्कुल सही बोला आपने, थैंक यू सो मच. Okay, so now next is beta rays. Beta rays are what? They are stream of electrons only. They are stream of electrons. So you know alpha rays as well as beta rays, they are deflected by electric field as well as magnetic field, because they are charged. So this beta particle has charge and mass same as on the electron. Therefore, beta particles are the stream of electrons only. Now gamma rays, third type of rays, they were not deflected by electric and magnetic field, and are gamma rays, and they were found to have no charge and negligible mass is they are represented as 0 0. It is represented as -1 E0. Beta rays are represented by -1 E0, alpha rays by 2 He4, and last one is, yes, gamma rays are simply, not we call it as photon, they are quantum, right? So gamma rays are electromagnetic radiation, because in case of light we use photon word. Okay, keep in mind that alpha rays are helium, not atom, helium, not helium particles, they are helium nuclei. Means helium has two electrons, so those two electrons are removed, so that become alpha ray, alpha particles. Beta rays, they are simply stream of electron represented as -1 is 0. Gamma rays has no charge and negligible mass, and they are simply electromagnetic radiations. They are simply electromagnetic radiations. That's all for the day.